This is the pre-lab video for Lab 3. How are the components of an unknown mixture identified? Before watching this video, you should have read the handout posted in Canvas for this lab and watched the TLC video. Speaking of the TLC video, I'm not going to rehash all of the elements of that video, which were really good. A lot of great information there. I do want to hit some of the highlights and give you some small modifications that we'll be making to the techniques described in the video. As they said in the video, we use thin layer chromatography to separate components in a mixture. We can use it to quickly analyze components of a mixture and figure out if it's pure. We can also use it to follow reactions, which just means we can use it to determine if reactions are complete because we can observe the disappearance of a starting material and the appearance of a product in TLC. This is a qualitative technique, not a quantitative technique. That means that this can just tell you if a substance is present in a mixture, or if it's not, it can't tell you how much of the substance is present. The technique you used last week, extraction, is more of a quantitative technique because you were able to separate a mixture of 3 components and weigh each of those components to determine how much of each was in the mixture. In this week's lab, you'll be analyzing an OTC, or over-the-counter analgesic. And the possible analgesics that you will be analyzing will include things like Anacin, Tylenol, and aspirin tablets. You'll also be looking at several, quote, headache powders. That includes Goody's Extra Strength, an old version of Goody's headache powders, and also BC powder. If you're not from the southern United States, you might not know that these headache powders are very popular compared to regular tablets that many folks take to relieve aches and pains. Now, all of these over-the-counter analgesics have different compounds in them. They can contain any of these 5 compounds, often in a mixture of maybe 2 to 3 components. For example, something like aspirin or Tylenol is only going to contain 1 component. In the case of aspirin, that's going to be, guess what, aspirin. And in the case of Tylenol, that's going to be acetaminophen. However, the other over-the-counter analgesics listed there, as I mentioned, have several different components in them, and you'll be analyzing them to determine what those are. As a side note, one of the components of the old version of Goody's powder contained a compound called phenacetin, and phenacetin is actually a precursor of acetaminophen, and it was banned from over-the-counter analgesics in 1983 because it caused severe kidney and liver damage, which acetaminophen can also cause, but it's not as bad at that as phenacetin is. Also note that caffeine is not an analgesic. However, it is put in many over-the-counter analgesics because it is a vasodilator and can help relieve headaches. So you will be assigned 2 over-the-counter analgesics to identify. And what we're going to do in the next couple of slides is we're going to describe the strategy for how you're going to determine what of the 5 components they may have in them. So here are 2 TLC plates. The first thing you're going to spot on the TLC plate is a mixture. What is that a mixture of? It's going to be a mixture that contains all 5 of these compounds. Then what you'll do is you will spot on the plate adjacent to that mixture. Here on the first plate, plate number 1, we've spotted aspirin and acetaminophen. And then we have a second plate here, and we've spotted, in addition to the mixture, caffeine, salicylate, and phenacetin. So that's plate number 2. You might be asking yourself, why didn't she just spot the mixture and all 5 of the possible components on the same slide. And one of the things that I have observed is that your skill level is not quite there to put that many spots on any one TLC plate, so that's why you're not doing it that way. Another thing to note about these TLC plates is you see that in this image I've written the names of all of the components down here on the bottom. Don't do this. Don't write here on a real TLC plate. If you need to make marks other than the line across and the few little hash marks to note where you're going to put your spots, that's fine. But any labeling or anything like that you should do up here. The reason is if you're writing on the bottom of the TLC plate, what's going to happen is you're going to start chipping the silica gel adsorbent off of the TLC plate, and the TLC plates will not work properly. It will be a mess. So as I said, I put labels down here to illustrate these images, but though you should label your TLC plates, you should not do it down there at the bottom where it's going to be in the developing solvent. Okay, so once you've got your plate spotted, what we're going to do is we're going to develop the plate to identify the components by their RF values. And notice that the mixture has separated into 5 spots. Oh, one of the things I did right as soon as I took it out of the TLC developing chamber is I drew a line marking the distance that the solvent had traveled so I could calculate RF values. So as I said, the mixture has separated into 5 different components, and I can see that the caffeine, the silicimide, and the phenacetin all have 1 spot at different RF values. And what I can see is that there is a spot in the mixture that has the same RF value as silicimide. Therefore, I know that this spot in the mixture is silicimide. I can also see that there is another spot in the mixture that lines up with caffeine, so that tells me that this spot must be caffeine. Finally, there is one more spot in the mixture that lines up with a spot of a pure substance on the plate, and that is this spot, and I can tell that this spot must be phenacetin. So I've identified 3 of the spots on the TLC plate, or 3 of the spots in the mixture from this TLC plate, and then I'd be able to go back and use TLC plate 1 to identify which spots in the mixture were aspirin and acetaminophen. Once I've identified all 5 spots in the mixture, I can then use that mixture to help me identify what my unknown analgesics are. So here what I've done is I have spotted the mixture in one lane, and I have been assigned unknowns 2 and unknown 4. That's, you're going to get your unknown in a vial with a number on it. And then I developed the plate, and it's separated out, and I took it out and I drew the line to mark the solvent front. That was very important. And now I can see, based on my data from the previous slides, that unknown number 2 contains 2 components that are in the mixture, one being silicimide and the other being caffeine. And I know this based on the data that I got from my previous analysis by spotting the mixture against the known possible components of that mixture. So now I have identified, the components that are in unknown 2, and so what I would want to do then is I would go and look on the different packages of the over-the-counter analgesics, and they will list all the components of those analgesics on the packages, and that's how I would identify my unknowns. And you'd be able to identify unknown 4 in the same way. Now, one of the things I want to point out is that all the spots I've drawn on these plates are all, the data here is all made up and not representative of the RF values you're going to see of these compounds in reality. I just made it up to illustrate it. Also, there is no unknown that contains only caffeine and silicimide. Once again, I just made that up for illustrative values. So you may be thinking about this. Okay, I'm going to need 2 plates to identify my the components of the mixture, and then if everything goes well, I'll just need 1 plate to ID my 2 unknowns. Yeah, that may be how it all adds up, but this is the first time you've ever done TLC, so you may make some mistakes, and that's okay. We have plenty of TLC plates, so you can do that, but it may take you a couple of tries to get everything right, so don't panic. Just a couple of notes about points of difference between what we're going to do in lab and the MIT video on the technique. We are going to be using for our TLC developing chamber a beaker with a watch glass on top of it as our TLC developing chamber. Works just fine. One of the keys here is you need to, as much as possible, keep this watch glass on top of the beaker. Why is that so important? You may be asking yourself. One thing is it prevents solvent evaporation, and the solvent that you're going to be using as your developing solvent is ethyl acetate, and there's the condensed formula for ethyl acetate. It's also often abbreviated ETOAC. And that solvent, as you might recall from the MIT video, is a bit polar, and so this is a solvent that works very, very well for this particular separation. However, if it starts evaporating, that's an endothermic process, and we live in humid North Carolina, and so what's going to happen is water condensation. And this is, as it says right there, but I'll just write it here for emphasis, is something that we want to prevent. Though ethyl acetate is polar and works well for this particular separation, water, you will recall, is even more polar. And if you start to get water in contamination in your developing solvent, what will happen is the developing solvent will no longer effectively separate the components of your mixture. So keep the lid on your TLC developing chamber. Another quick note is that, once again, we want to use only pencil to write on the TLC plates because inks are soluble in TLC developing solvents, and you will get, instead of your TLC of your analgesics, a lovely chromatogram of your pen ink. To visualize the TLC plates, we are going to be using UV light, just as described in the MIT video on the technique. We're also going to be using iodine vapor, and that is, as it says here, that's a destructive technique because what happens is that iodine can react with some of the compounds, not all of the compounds, but it can react with some of the compounds, and it'll form brown spots on the TLC plate. And that's a great technique because since it doesn't react with all the spots, it can help you differentiate between some spots that may have similar RF values, but it's a technique that you want to use after you visualized everything with UV because it reacts with the compounds and destroys them. Just a quick note on some things that I see during this lab that are problems. Sometimes students apply too much sample, and so you get a big blob like this, and that's not good. Another thing that can happen is that you see, rather than having the spots move straight up the plate, they go up at an angle like this, and that's usually because the solvent front didn't move up the TLC plate evenly, because you had a big gash down here, and we'll show you how to trim up the plates in the lab so that the solvent front will move up evenly. One of the things you should do is, after you've spotted your slides, before you've developed them, one of the things you should do is you should check them under UV. And if you can see these spots under UV, these are all white compounds, so you won't be able to see them without the UV. But if you can see these spots before you develop your sample, then you know you have enough to see on the TLC plate, and that can prevent the other error, which is not being able to see your spots after you develop your TLC plate. Okay, so your goals for this lab are to get all your TLC plates and calculate RF values for all your spots. You're going to identify your unknown components using the RF values and using their appearance under UV and iodine. So those are all important things to have in your lab notebook. You should, when you have the report that you're supposed to write, one of the things that you're going to do is, as I said, identify what unknown over-the-counter analgesics you have, and you'll need to explain the data that supports that conclusion that you're drawing about. Do I have Anacin? Do I have BC powder? How do you know what you know? That's really important. One of the other things that you're going to be doing this week is we're going to be making moonshine. Yay! No, we are going to be making alcohol. How we're going to be making alcohol is we are going to be doing a fermentation. Specifically, we're going to be fermenting sucrose with yeast, and that is going to give us ethanol, which we can then isolate through a technique called distillation, which is what we'll be doing in Lab 4. But this takes a week to happen, so we want to set it up this week so that we'll have the ethanol to distill in the next week. So you should look at the first part of the handout for Lab 4. What you're going to put in this 500 ml round bottom flask, and this is all in the handout: 40 grams of sucrose, 3 grams of yeast, 200 milliliters of DI water, and 35 milliliters of pasture salt, which is a magical mixture of several different salts that keep the yeast happy and fermenting for a week. We have this system right here. This is to keep oxygen from getting into the system, but allow the carbon dioxide that's being produced as the yeast ferments the sucrose to be able to bubble out. We'll have some calcium hydroxide solution in this tube that will react with CO2 as it comes out. But that's basically it. It's a pretty simple setup. Yours is going to look a little bit different because we have found that it's very difficult to balance the round bottom flask safely for a week on a cork ring. So what you'll do is you'll actually clamp up your round bottom flask, and you'll have all your solutions in here, and then hopefully CO2 will go through here, leaving ethanol and water that we can distill in the following weeks. And this is something that you're going to set up. There's only going to be one setup per group, so you'll be doing distillation with your lab partner. So those of you who wanted to have an opportunity to work together, this week is your opportunity to do that.